I am in BS Physics department and my ID is 005. Uh, and my presentation topic is mass spectroscopy. Uh, First of all, I want to tell you about this spectroscopy. The question arises, what is spectroscopy? Spectroscopy generally is based as the area of science concerned with the absorption, emission, and scattering of electromagnetic radiations by atoms and molecules, which may be in the gas, liquid, or mobile phase. Spectroscopy is used in physical and analytical chemistry because atoms and molecules have unique spectra. As a result, these spectra can be used to detect, identify, and quantify information about the atoms and molecules. Spectroscopy is also used in astronomy and etc. Types of spectroscopy. There are so many types of spectroscopy, but some of their fluorescent spectroscopy, X-ray spectroscopy, flame spectroscopy are also has three types: atomic emission spectroscopy, atomic absorption spectroscopy, atomic fluorescent spectroscopy, plasma emission spectroscopy, infrared spectroscopy, NMR spectroscopy. Except these, there are also many types of spectroscopy like photothermal spectroscopy, thermal infrared spectroscopy, UV visible spectroscopy, and my presentation topic is max spectroscopy and also other mass spectroscopy. Mass spectroscopy, also called mass spectrum, is an analytical technique by which chemical substances are identified by the sorting of gaseous ions in electric and magnetic fields according to their charge to mass ratio, and charge to mass ratio is also represented as m over z. An instrument or some other examples or other definition of mass spectroscopy is an instrumental method for identifying the chemical constitutions of a substance by means of a separation of gaseous ion according to their differing mass and charge, called mass spectroscopy. What is the question is, what is the basic principle of mass spectroscopy? The basic principle of mass spectroscopy is the most accurate method for determining the molecular mass of the compounds and their elemental composition. In this technique, molecules are bombarded with a beam of energetic electrons. The molecules are ionized and broken up into many fragments, some of which are positive ions. Each kind of ions has a particular ratio of mass to charge, that is, a ratio value. For most ions, the charge is 1, and thus ratio is simple the molecular mass of the ion. And then coming towards my slide. Principle. The basic principle of mass spectroscopy is to generate ions from either inorganic or organic compounds by any suitable method, to separate these ions by their charge to mass ratio, and to detect them quantitatively and qualitatively by their respectively m over z. M over z represent the charge to mass ratio and abundance. And then this is the diagram of mass spectroscopy. In this diagram, there are four main stages: ionization, observation, detection, and reflection. I am telling about their functions. First of all, I want to tell about the function of ionization. And ionization is the first stage of mass spectroscopy. The ionization chamber is a region in which atoms of the unknown materials are excited so as to make them lose electrons. Sometimes the energy needed for exciting the atoms is obtained simply by heating the sample. When atoms are excited, they lose electrons and become positively charged particles known as ions. And then the second stage of the mass spectroscopy is acceleration, and I'm here and I'm thinking about the function of acceleration. Acceleration, the positive ions created in the ionization stage are accelerates negative pairs at a speed dependent on their mass. In other words, lighter molecules move quicker than heavier ones. So ions of different mass travel through the spectroscopy or spectrometer at different speeds. And the third stage of mass spectroscopy is the deflection, and the function of the deflection is the lighter molecules move quicker than heavier ones. Deflection is the magnetic field. The ions are then detected by a magnetic field, and the extent of reflection is again dependent on mass. So, ions of different mass travel through the spectrometer or spectroscopy at different speeds. And then I'm telling about the fourth and the last stage of mass spectroscopy, and the function of the last stage of spectroscopy is the final element of the spectroscopy is the detector. The detector records either the charge used or the current produced when an ion passes through a hit a surface. And then I am telling about the work. How does mass spectroscopy work? Mass spectroscopy can measure the mass of a molecule only after it converts the molecule to a gas phase ion. To do so, it imparts an electric charge to molecules and convert the resultant flux of electrically charged ions into proportional electric current that a system then records. Uses of mass spectroscopy. There are so many uses of mass spectroscopy, but some are there. Testing for the purity of pharmaceutical substances. Testing for the identify of pharmaceutical substances. Analysis of pharmaceutical substances. Quantitatively analysis, for example, inorganic materials, blood plasma. Structural analysis of blood, natural substances, synthetic product, conversion products of pharmaceutical substances, and metabolites of pharmaceutical substances. Exactly. The question is what information can be determined by the mass spectroscopy. We gain information with the help of mass spectroscopy by molecular weight, molecular formula, protein sequence, isotopic incorporation, and the last one is the protein sequence. And the next question is if the only ion that is present in the molecular weight, this means that only ion present, not any other thing also present. Mass spectroscopy provides a way to measure the molecular weight of a compound and is often used for this purpose. However, the molecular ion often fragments to a mixture of species of fluid M over Z. And I'm telling about the M over Z. M over Z represent the charge to mass ratio. And the last one is applications of mass spectroscopy. The applications of mass spectroscopy are sensitive detectors of isotopes based on their masses. They are used in carbon dating and other radioactive during dating processes. The combination of a mass spectrometer and a gas chromatograph makes a powerful tools for the detections of trace quantities of contaminants or toxins. A number of satellites and spacecraft have mass spectroscopy for the identifications of the small members of particles in intercepted in space. For example, the SO satellite uses a mass spectroscope to analyze the solar wind. Mass spectroscopy are used for the analysis of residual gases in high vacuum system, and also so many examples. Some are here in my presentation: pharmaceutical analysis, bioavailability studies, drug metabolism studies, identifying drug targets, environmental analysis, forensic analysis, and so many other applications of mass spectroscopy. That's all from my side.